Alright, starting lesson 0.4a, rational expressions. For example 1, we need to find the domain of the expression. What does that mean, to find the domain? It simply means find the x values that work. Or you could also find the x values that don't work. Alright, so let's think about what numbers can we plug in here where if we simplify everything, it doesn't work. Well, in this case, there are no numbers that do not work. You can plug anything in here and it'll work out to be fine. So all row numbers would be the domain. For part B, looking at this expression, what numbers could we plug in for x that'll make this expression not simplify or not work? There's nothing. Everything works. All row numbers work. But there's this restriction here. So from the numbers that do work, we only want to consider those values that are greater than 0. So we would say all positive real numbers. Okay, once again, all row numbers work, but applying this restriction, then we're only working with the positives. For part C, what do we do here? Okay, what's the domain going to be? Well, we're working with this radical here, and we can only take the square root of a positive number. That's the key idea, a positive number. So whatever 6 minus x is, it has to be greater than or equal to 0, because that's the only way you could take the square root of it. This quantity has to be greater than or equal to 0 in order to take the square root of it. So setting it up in this way allows us to figure out the x values that do work. In other words, what our domain is. Divide by -1, and don't forget to flip the sign. Alright, so the domain is going to be all real numbers x such that x is less than or equal to 6. Alright? And that's domain. If you're not clear on what domain is still, please ask me for help. Alright, write the rational expression in simplest form. Okay, here we have nothing but values being multiplied by each other. Here we have a difference. Alright, can we factor that? For the denominator, yes, we can factor the denominator. We could pull out a y. So I end up with y times x minus 1. On top, I still have the 2x squared times y. And the y's will cancel out, leaving us with 2x squared over x minus 1. And we're done. Alright, going to the next problem, we're going to have to factor the numerator and the denominator. Alright, so for the numerator, I got to figure out two numbers that add up to 8, multiply to give me -20. And then two numbers that add up to 11, multiply to give me 10. So for the first one, we have 10 and -2. And for the second one, we have 1 and 10. So on top, we're going to have x minus 2 times x plus 10. On the bottom, we're going to have x plus 1 times x plus 10. Okay, now we have these common factors that cancel out, so we're just left with x minus 2 times x plus 1. Now for many of these problems, when you look in the back of the book at the solution, you're going to have something like this. Now, what does this mean? Where does it come from? Okay, if you just look at this expression here, and I ask you what the domain is, well, it's going to be all row numbers except what? The numbers that make this expression undefined. Well, what makes it undefined? Whatever makes these quantities 0. So one of them would be -1, and the other one would be -10. Now, when I simplified the expression, I ended up with this. So I still see this here, but I don't see this piece anymore. This is the piece that tells me that in the domain, x cannot equal negative 10. But looking at this expression now, you don't know that. But going from the starting expression to the ending expression, the domains have to agree. Okay, so that's why at the end, you also have to include that x does not equal negative 10, because that's not part of the domain. But just by looking at the expression here, you know that negative 1 is also not part of the domain. So just watch out for that. You may have another question about, well, why didn't we do that over here when we cancel out the y's? That's because y has nothing to do with the domain. X is what has to do with the domain. On to the next example. All right, perform the multiplication and simplify. All right, first thing we're going to do is change this from a division problem to a multiplication problem. All right, and I'm going to factor the numerator using the big X method. What two numbers add up to negative 14? Multiply, give me 49. Negative 7 and negative 7. What is this here? Well, that's simply a difference of squares. So on the top I have x minus 7 times x minus 7. And this is a difference of squares. So I have x minus 7 times x plus 7. And then times x plus 7 over. Let's factor out the 3. X minus 7. Alright, so x minus 7's cancel. X plus 7's cancel. X minus 7's cancel. And I'm left with 1/3. Alright, and let's not forget about having a common domain. So going back to this expression here, we know that positive 7 cannot be part of the domain because that makes this 0. And we know negative 7 cannot be part of the domain because that makes this 0. Alright, but now we just have this 1/3 here. And just by looking at this 1/3, we don't know that negative 7 and positive 7 aren't part of the domain. But we have to ensure between the expressions that there is a common domain. So you have to list that x cannot be equal to positive or negative 7. Alright, just watch out for that. Done. Going on to the last example, we have to factor the denominators. For the first one, we have 1 and negative 2. For the second one, we have negative 2 and 4. So I end up with 2 over x plus 1 times x minus 2 plus 10 over x minus 2 times x plus 4. All right, now I have to find a common denominator. So what is the least common denominator? Well, this one has an x plus 1. The other one doesn't. They both have an x minus 2. Cool. And this one has an x plus 4. So I need to get both denominators to look like that. So what are you going to do? So I'll multiply this one here, top and bottom, by x plus 4. And I'll multiply the other one by x plus 1, top and bottom. So I end up with 2x plus 8 over, I'm just going to keep this common denominator. I'm not going to work everything out. Because at the end, you may end up with factors that cancel out. Then I have 10x plus 10 over the common denominator, x plus 4 times x plus 1 times x minus 2. All right, then just adding like terms here. Watch out for this operation, because if there's a negative ever there, it has to distribute to both parts. I see students often make a mistake with that, so pay attention to that. So I end up with 12x plus 18 over x plus 4 times x plus 1 times x minus 2. And I could still factor the numerator. I could pull out a 6, so I end up with 2x plus 3 over x plus 4 times x plus 1 times x minus 2. And in this case, no factors cancel out, so that's all you can do. We're done. All right, begin the assignment at the bottom of the web page.